Hey everybody, it's Nick. Today we got a tutorial for you that's going to be continuing our discussion about three-dimensional topology. So we started off last video with numbers and we saw how those could be turned into points. Today we're going to talk about how points can generate curves and that we can get points back from curves as well. Uh, and the kind of focus of it is going to be to go back to the kind of Mark Foran's stuff that we looked at with the lab. You can see these kinds of designs that are on the panels that are on the canopies that he and his team designed. You can say, well, how do you get those kind of funky, kind of patterns? And so that's where we're going to end up when this is all kind of said and done. Is we're going to have a couple of different methods for generating these things that we can then tile onto our canopy surfaces. So that's where this is all going. And you can see I got this kind of example already, like just to kind of demonstrate for you. I've got a program that takes a curve and kind of uses that to distribute these things along a surface, and we'll talk about that more later. So and the easiest way to illustrate the basic relationship between points and a line is just to go ahead and make a real simple line object. We're going to make a point at 0, 0, and then we're just going to make a point somewhere else. So I'm going to set that point. Let's make sure that I get this right. There we go. And then I'm going to go ahead and set this point, and then make a line object. And a line is just pretty easy. It just takes a point A, point B. So a start point and an end point, and that's it. You're just going to get, a parametric line. And if you give it a list of points and everything, you're going to get a line, but that's just real simple. It's just a straight line. The other way that you can make a line that's really handy is you can do what's called a line SDL. And this is really, really nice. So you have a start point, a direction, and a length. And the start point, is just a point. So we got, 0, 0 right here. Let me go ahead and get rid of this here. I might have I got the wrong point. I'll just do that. There we go. And then the direction would be a vector in any direction. In this case, I might want the direction to be x. So just to make sure I get this, I'm gonna go ahead and go unit x. And then for length, I can go ahead and put in, some kind of a number slider. Make this a little bit better. I had it. And you can kind of see the green here. And in fact, so we've got a point, we've got a line. Really easy way to get that. If you have a line that you didn't create, you can get the endpoints of the line with this component. And so that's now the start point and the end point. And so you can actually get that out of here, which is kind of cool. So the endpoint is there at the same distance here. And again, if I want to make that line go up, I could just do a y unit y. So now I've got it kind of going up and down. Excuse me. And that can be really handy for a lot of reasons. Like it's kind of like the difference between range and series. Like if I kind of know where I'm starting and I know the length, but I maybe don't know where to calculate that point, this is really handy. If I know exactly where that point is, of course I could just do like a regular line command. But that's really nice to be able to do. So go ahead and do that. I'm gonna go ahead and switch back to double click that. Go and switch back to the unit x again, and plug that in for the distance. And I don't need to worry too much about this. Go back to this idea that we had earlier of like the graph mapper, and I'm gonna do a couple things here. So hang on, I'm gonna give this a little bit more length for the line and zoom out. And once you've got a line, you can do all kinds of interesting things to get points from it. So I could go in and you can actually say point on curve, and you can plug. I'm gonna get rid of this. You can plug this in to the line, and you can see this is 0.5, and so I can actually move along that line. So 0 is the start point, 0.5 of course is the midpoint, and I can actually just, if I do a right click, I can change this. I can do a quarter point, 2/3 point, end point. And that can be kind of handy for different things, like finding a point along the line, obviously. You could also do a thing where, like, if you had an object, for example, a cylinder, which might represent a column, or might actually be a column in your case. Let's go ahead and make that a little bit taller. There we go. So you can make that along the line there. You can also do things like there's actually a curved middle, which will just give you the middle. You don't have to do that, but that's all it's good for. Sometimes that's all you want. Something else I use a lot is divide curve. And this is really handy. We use this pretty frequently in architecture where we're just trying to divide something up by some number. So you say I have a curve or some kind of line, and I need it to be a certain number of units. And so I'm going to go ahead and make a slider here. Go for n. You can see as I increase it, I get more points on that line, and they're evenly divided. And that's pretty handy. And again, if I'm just trying to do something, shouldn't have deleted that, but if I go through, I can make a lot of objects at those points. A lot of these take a number as base input. But again, what if that's not exactly what I want? Like, one other way you can do it is you can do curve length, or curve length at, and not that one. Sorry. We're going under analysis here. There's a lot of different things you can do to get things out of curves. We're going to evaluate length. You've got the curve. You have the length factor, which is a number between 0 and 1 again. And then that's going to give you the curve. And you can say, well, why is that any different from point on curve? Well, that's point on curve. It gives you 1. In this case, actually, if you did something like a panel, well, no, let's do a range. We know what ranges are. So if I plug in a range, remember we're going from 0 to 1. 0 being the start, 1 being the end. If I divide this by 10, I'm going to get that length, and that's going to give me that. So it's a little bit different way of approaching it than the number of items. I can actually look at the length of what I want, and might be more useful to kind of look at this way, but where you can do something like, I could say like 0.33, 0.5, 0.75, 0.8, and go multi-line data, so I can get them at a specific interval. It's all depending on the switch here. So this means the length is normalized. So that means that it actually is only from 0 to 1. If I say that that's not normalized, if I say false, I realize that they just kind of popped out there. So go Boolean false. Okay. Now the length is the actual length. So we have 48 units to work with. I could actually go in with my panel and I can say, okay, well, sorry, 50. If I go along there and I say, well, I want something at 10, then I'm going to get it at 10. So I can say 10, 12, 45, 48. Remember multi-line data. There you go. So now I can actually get that in actual units. So if it's normalized, you just go from 0 to 1. And you can use multiple numbers. And that's, again, very similar to the point on curve, except that you can do multiple numbers. Or you can do it by length. And, again, if I did that, I could put a series in under that length. Just with those numbers. So just, depending on what kind of information you have, that's going to be able to let you like divide that line or that curve up and like get you points where you like need them to be. And that's incredibly useful. We do a lot of things with proportions, and like the length of the different materials we have, so that's gonna be something that's pretty handy. All right, so now we're gonna take a step back and we're gonna kind of review a little bit. So speaking of series and range and all the stuff that we did before, we are going to, let's see, construct point. We're going to go back to the graph mapper again. Um, yeah, just fix this a little bit. Okay, so we got the number of things, and we're going to have steps. Not too many. It's too big. There we go. All right. So we're going to make those, and then with the graph mapper, we are going to go ahead and throw on a range. That's a pretty familiar pattern that I hope you guys kind of get now. To go ahead and take the number of values. You're going to add 1 to it. And then we're going to add a multiplier. And let's see here. I don't know how big I'm going to need these to be. So I guess I'm going to do this number slider here. And for the Y, let's see. Oh, see. On that view. There we go. Okay, now we got something going here. Let's see. 20 values. 22 values. Uh-oh. I did something wrong here. I think maybe I need to go -1. There we go. You don't want to end up with any extra there. Sorry about that. That looks right. Okay. And I could probably make these a little bit taller. Just for, there we go. Okay, so back to the old kind of patterns that we had here. So we're making a simple sine wave. We made some points with the series, and then we used range and the graph mapper, and we multiplied them to give them some amplitude. And now we've got our thing. So now that we've got these points here, you already saw it before. I think we went ahead and you can do, polyline. And if I plug these in, I get polyline. And you can see actually the way this looks is it's a series of straight segments. Okay, so that's a polyline. So polyline just means like a lot of lines, right? And we're talking about lines. We're actually talking about connecting with a straight line between 2 points. And that's useful when we want things to have a hard edge, when we want things to have a specific angle, but not when we want things that are like smooth, right? So that's a polyline. Again, it's kind of a cousin of the line. What you can also get though is called a NURBS curve. NURBS, we'll get into this later, but it's a non-uniform rational Bezier spline or B-spline. And what it basically means is just it's fancy math to make something smooth. It's kind of resolution independent. So we're gonna take these points, you plug them in, and you'll notice that this line here, you can see how it's actually pretty smooth again. But you can see though, it's not hitting those points. It's not coming into contact with those points. It's finishing off at the end point and at the start point. But along the way, like its smoothness is actually coming. It's actually out of this, and that's because of the way that NURBS work. NURBS have these sort of like control points, and the control points actually are what give you the curvature. So for example, if I make a curve here using the NURBS tool here, a control point curve, you can see that this control point, even though it is controlling the curvature of it, it's not exactly like attached to it. Not in the way that it would be if it was this polyline curve. So you've got the control points and the number of points in a curve. matters. And then you've also got the sort of curve, the curve sort of like the curve degree, and the curve degree is basically like how many is how when you grab one of these points, how it affects the other points. So for example, I'm going to go ahead and add a couple of different points here. Well, I messed up here. So when I make this curve, I have like the degree, okay, and the default degree is 3, and that means that it affects the next three points in the curve. If you have a degree of 2, it's only going to affect the neighboring 2 points. And so you can see what that gets you. It actually bends that. So you see it doesn't affect this point. It's affecting this point that I pulled and the neighboring point. And if I pull this one, it's going to affect this point, not that endpoint. And basically, it's a way of kind of measuring uh, the kind of effect it has, how tight the curve is, how close it might get to that control point, or how it doesn't care about that basically. Um, and so if I go into this curve here, let me just really quickly make a number slide here. So you can see if I go back to curve degree of, I can't do 0. If I go to curve degree of 1 is indistinguishable from a polyline curve. And then if I go to 2, you can see where it starts to affect it more. And if I go to 3, 4, 5, and the effect of it is that it just creates it's a smoother curve, but again, the precision of it it doesn't care quite as much whether it hits all these points. So something, and you're like, well, okay, Nick, what if I want a smooth curve and I want to hit those points? Like, it's important to me to hit those points. Well, you can go in and do an interpolate curve, and interpolated curve will actually get through all those points. And you can change the curve degree of the interpolated curve as well. You move these out of the way here. There we go. And you can kind of see, and the interpolated curve will only allow you to do odd numbers of degrees because of the way the math works. You can see there's not like a whole lot of difference though. Once you start getting into like 5th degree or 7th degree curves, 3rd degree is the default. Anyway, so let's just go ahead and throw on custom preview for some of these. Swatch. Go. So we can actually see what the difference is with these different curves. Just a handy kind of device here. Okay, so the polyline curve, right? Got your kind of straight lines connecting everything together. That's the red line. The green NURBS curve is a very smooth curve, but it's dependent on thinking about like the curve degree, also the number of points in the curve like affected as well, right? If this is the number of points that are affected, whether that's, to the 4th power, or to the 4 points, or 3 points, or 2 points, then the number of points is very important, right? Because that's what you have to sample from. And then lastly, an interpolated curve, which is a special flavor of NURBS curve, that's going to go through every single point. It's going to make sure that it goes through every single point. But you notice, look at this, how the interpolated curve will sometimes go kind of to the outside, or I guess in this case, the inside of it, and then it's going to go outside. Now it's coming back through to the outside. Doesn't really obey anything. And then if you've got the green curve, which is the NURBS curve, looks like it always pretty much, well, nope, kind of goes to the outside. inside, a little bit outside. So they're actually kind of like the opposite of each other, the interpolated curve um, and the NURBS curve. And then lastly, the kind of polyline is just going to straighten. It's just going to follow it, but not going to be smooth. So just the difference of different things, it matters depending upon what you're trying to fabricate or whether the inside or outside of your object is really important, when you're trying to offset that curve. Um, so those are what the different curve types do. So we've looked at the different types of curves and how to get those from points. Going back to the curve tab here, so I'll show. So you've got a lot of curve primitives here. So this is where you're going to start making curves from lines. Sorry, from points and from points and numbers. And so we have line where we came from. We have line SDL. You can go back though and see these kind of orange ones here. These are really core kind of primitives. You have circle, ellipse, arc, rectangle. So these are all really basic ways of getting curves into Rhino, things you might be familiar with. The other one to look at is polygon. And polygon again, like most of these will start with a point, and that's the kind of base plane, and usually that's 0, 0. And they usually start on the top plane. You can see that there. And then in this case, you have a radius, and you have a number of sides, and if you're going to fillet it. So I'm just going to go ahead and put some stuff in here. So again, go back to the radius, make it pretty big. If I go to the number of sides here, so of course you can't have a polygon with less than 3 sides. Go to triangle, squares, etc., etc., etc. You can just rotate those if you need to. So that's basic polygon, and then the next thing you want to look at are like the utility tools. And of these, the interesting ones, we've looked at join curves before. You can also get offset curve, which can be really useful. And that's like we've seen when we're drafting, where, like go ahead and make a number slider here. 10, 0, greater than 10. So we go in for the distance here. And so, if you're going to offset out, you can change that here. Offset out or offset in. So we go negative. That can be pretty handy as well for various reasons. So under utilities, and you can transform a curve to a polyline. One thing I didn't talk about too is rebuilding curves. So if you have a curve that you created and you want to change the degree of the curve or the number of points in the curve, you can do that with like rebuild curve. And I just want to show what that kind of looks like here. So let's go back to, so the degree of the curve, remember we talked about that's how affected the different control points are. So you can see what that ends up doing though, is that you create something that's fairly rounded. And that can be kind of an interesting way to round something. But, depending upon the curve degree, you can see the kind of results you get. And you can kind of dial it from there. If you go down to curve degree of 1, you're going to lose the shape. See how it really takes away those corners. You can also go in and change the number of points, and that could really affect something. So if I don't even have enough points, I'm really going to lose that shape. Like I'm not even going to have the hexagon. And look at that. If I get to the 3rd degree and I've got the same number of points, I actually get a circle, more or less. So you can really transform things, to inscribe, different curves and things. See how that goes with 6 points. Very interesting, right? 5 less points. How it kind of adapts to that. Almost get a triangle there. So something worth experimenting with. But that's rebuild curve. So things to pay attention to. So here's how you generate different things. You also have all your spline tools. So we go interpolate, NURBS curve, and then utility. So what are different ways that we can change or edit or sort of like manipulate the curves we have. And then analysis is where we come back and we get points from them. We can get different information from them. So there's lots of different commands. And This is all kind of overwhelming, I know, but the way that Grasshopper really starts to work for people is the more you kind of see patterns and you start to look for different ways to get the information you want and kind of asking like, well, I need to get the midpoint of this, or I need to get the center of that, or I need to get the third point of this thing, and that's how you start looking for these different components. And over time you'll start to kind of recognize them. There's just so many, from the get-go, and I wouldn't expect you to know what they all are, much less to understand them all. But it's good to kind of see like what's possible and like what the effects of those things are. And that's what we're doing right now. So so there's different things you can do when you have, and this will work for any kind of arbitrary shape too. So if I go in and I was just to draw, some kind of crazy, shape, I could go ahead and put that in for a curve. That's a curve component. So I'm gonna set that curve, and I'm gonna go ahead and skip that, and I can start to hide this for now. Start to look at the shape. And sometimes sometimes offset curve positive numbers are inside and negative numbers are outside. We'll talk about that later, but depending upon the direction of the curve, you got to be careful about like what that offset actually does. Got kind of a ghost. That's kind of cool. So yeah, like especially in this case, like the number of points I have is really going to affect. There we go. How close I can get to that curve. And in this case, boy, looks like I need a lot more points. There we go. Now we're starting to get something that's kind of approximating that. That's kind of a neat way to get something organic from that. And that's how you end up getting, into some of these forms, believe it or not. They're just kind of like looser versions of some of these offsets. Okay, so there's that. All right, so for the last piece of the puzzle, we're gonna bring this all home, and we're gonna start to generate some different kinds of panel patterns that are, again, are kind of similar to the stuff we saw on like the very many projects. So I'm just gonna draw a curve for now. And this can be any arbitrary shape, but I'm gonna go ahead and go with a rectangle just to make things easier. And so I'm gonna go ahead and put that inside of a curve container. And at that point I can hide this. Now we're gonna be doing something right now. We're gonna start with something that's effectively random, just as a way of generating points, just for something fun. And to do that, just go ahead and go into the vector tools, and you got these grids here. And you can, if you have something that's actually easy, that's just kind of a like a square form, you can go ahead and use a populate 2D. And so in this case, you just take this for the rectangle and go ahead and plug it in. And then we're going to go ahead and make a number slider, a couple of them actually, with 100 inside for this instance. And it's going to generate 100 random points. And then the C just gives us different things. And one thing you want to recognize right away is that the points get very close to the edge. And if I'm going to start to like chip away at these things, I need some material on the edges so that I can put in like fasteners or rivets. And so I actually can't go all the way to the edge. So what I'm going to do briefly is just go ahead and offset the curve. And you can already tell that this is kind of flipped inside out. So what I can do really easily is just give it something like, and it depends on the scale of what you're doing, but I'm just going to make a slider from -10 to 10, give it a real number, and hope that that's going to be good enough. There we go. So I'm going to go inside a little bit, and then I'm going to go ahead and plug this in for R, and that's going to move me inside. And I like that better. Okay. So then I'm going to do a Voronoi. And you've probably heard of Voronoi. If you haven't, they're really common in computation as a way of kind of creating organic patterns. Um, it's like kind of an aesthetic, but in this case, we're going to go ahead and use it. So Voronoi wants a point. We've got plenty of those, and the radius, we're not going to mess with that right now. And then the containment boundary, which is actually going to be this. and that's gonna go ahead and kind of clip things for us. And you know, again, if it's too close or too far away, we can go ahead and move this in and out. But you can see like it's an algorithm. I'm not really going to get into it, but basically it attempts to draw a cell around each one of those points, and they tend to be 4 or 5 or 6 sided. Um, and then that's kind of what you end up with. And what we're going to do with that is we're going to go ahead and we're going to scale each of those. And so we're going just like we did before with our when we made our canopy and we scaled down points to create kind of offsets. Um, so go ahead and do number slider for F. And to find the centroid of these things, you go into curve, analysis, polygon center. And it's different, you know, the center of the vertexes, center of the edges, or the center of the polyline shape. I tend to like shape for my center. Let's go ahead and hide these again. And, you know, if you give yourself a little bit of that, you can kind of see that offset, which on its own might be pretty cool, but we're going to go ahead and rebuild that curve and give ourselves something a little bit more organic looking. So, you know, probably 5 or 6 points for Voronoi for the number of points. And the degree, we've seen, you know, 2 or 3 for the degree. It's going to give you something nice and organic. And so now, you know, depending on what you like, you know, if you have less of them, you're going to have you're going to have a larger shape. You know, if you don't like it, you can change it. And depending upon, you know, if you make them pretty large, you might decide to kind of play with this a bit more. The more points you have, the closer they're going to hew to that shape, and they're going to become, you know, you just kind of got to get the sweet spot, but, you know, they're going to stick more to the original shape, and your mileage may vary, but anyway, so that's kind of a method of getting that. And then, of course, if you were going to, these are very easy to cut. Excuse me. You would just bake the outside and bake the inside, and then go ahead and laser cut that. Um, and I think, you know, and that's pretty cool. But it's not like super interesting. So one thing I'm going to do that's going to change the formula a bit is just take a line like I showed you guys in the example. And I'm going to go ahead. So I'm still going to keep the outside box. And I'm going to go ahead and keep that offset too. But instead of just doing random points like I had, I'm going to go ahead and divide curve. And I'm going to go ahead. Oops, wrong curve there. Let's make a new curve. That doesn't do anything. And I'm going to go ahead and set this as the curve. So now I've got some points along that curve. And I've got a lot actually, but I'm going to go ahead and dial that down a little bit. And then plug those points in for the Voronoi. And you can kind of see, like, if I go back down again, you know, how I ended up with the example that I showed you, where if I take this curve, you know, I can modify it. You can see how those shapes respond to that form, you know, sometimes in better ways than others. But you can definitely get patterns that you have more control over. And of course, like you could write a script that could control the way the curves are generated or randomly generate that curve. But it's a little bit more interesting, you know, than what we just had before. So again, just there's a box that kind of restricts it so that it doesn't cross the outside. Points on a curve. I got the Voronoi, find the centers, offset, rebuild, and that's going to give you that kind of curve design. So that gives you a little bit more control than you had, you know, like before. So to kind of play on the theme again, we don't always make boxes. So what happens when we have a shape that is irregular? Well, I'm going to talk about that. So going forth, I'm going to go ahead and set this pattern. I'm gonna go ahead and turn this off for now because it's just gonna get in my way. And I'm gonna go ahead and kill that curve too. So I've got my offset, and depending upon your scale, you're gonna have to remake this. And then we're gonna go in, and I'm gonna go ahead, and I got to be a little tricky with this because I can't just use a populate 2D anymore. Because if I do that, it's actually gonna be, it's not gonna care. It's gonna float in a square outside that area because it uses a rectangle. What you can do is do a populate geometry component, and it won't work with a curve because it's just going to put points along the outside of the curve, and I don't like that. So what I can do to trick it is I can make a boundary surface, and I can make that, so I turn that into a surface, and now I can put points inside of that geometry. And then once I've got that, I can start to play with things, the way that I used to. Just got to get these things working again. Hang on a second here. Oh, actually, I'm wrong about that. Boundary is still going to be rectangular, so I gotta use a little bit different method. You can see, I'm gonna kind of hide this again here. You can see the issue is that the Voronoi actually creates this very huge box and it goes outside of it. So I've gotta restrict it first. Um, so I'm gonna do looking for a boundary intersection. So there's a whole panel here of like intersections, and I just gotta find um, the right intersection here. Oh, I want a region intersection. That's right. So the region that I have is the curve, and then these curves, and that should actually output the. Let's see here. Oh, let me just try this here. Okay, for some reason that works. Okay, so the boundary, the Boolean intersection of the region. So the region is the curve, and then the other regions are the Voronoi, and what you end up with is the leftovers here. So you're going to plug that in for your centroids, and let's see here. Make sure I got all this. The geometry. Oh, yeah, the geometry is this. There we go. Perfect. So got my offset. Go to a surface, populate geometry, my region intersection, centroid, scale, rebuild. Um, yeah, so that works. So similar. Let me go back and see if I can make this curve here. There we go. Um, yeah, and then the same thing is true if I have my curve in there. Although a little bit less exciting this time. But so there's that, and go ahead and plug in your number of points again and your seed. You can pack it smaller or larger. But so again, the process with an arbitrary shape is a little bit more difficult because you have to make it into a surface first and then get that populated and then take the region. But it's not too bad. Last kind of Voronoi thing I'll show you is a little bit different method. So we've done a lot with like random points. You can do interesting things with this method if you have more regular points, and that's if you use something like the radial grid or rectangular grid or the triangular grid, any of those kinds of things. You can also use your lunchbox tools to kind of create similar structures. I'm not going to cover that right now, but if you go back to the vectors, you can go ahead and have like a radial grid, which is really kind of interesting. And just kind of, there's a way to do this parametrically, but I'm not going to do it right now. I'm just going to draw. Just gonna draw a box around it, so don't tell anybody. But just to make this really, really quick, I'm gonna do that, and then use that for my Voronoi. So let's see here. Yep. So the points I'm gonna be using are coming from here, and I'm just gonna go ahead and flatten all these. They don't really want to be in that structure that's in there. So I'm gonna go ahead and flatten them. This is gonna be a warning because you are gonna get overlapping points, but I don't really mind. And then for the boundary, I'm gonna go ahead and select B. Um, and that's gonna give me this kind of Voronoi structure. And then if I go in, just use the same method I had before. I'm gonna go ahead and scale each of these, find the polygon center. And actually, I'm gonna go ahead and let this show for now so you can see, and that's kind of neat, like in and of itself, just kind of as an offset. But really, if you start to rebuild um, those curves like we have been, you get some kind of neat effects. So 10 and 10. So let's go 3 or 4 points for the number of points, and probably a third degree curve again. And you get something like that. And you know, I can go in here, and so this is the size of the pieces. You can see the smaller they get, you get some different patterns. And then the number of cells and the radius position, which is also kind of interesting as well. So that's kind of fun to play with. I think this is, yeah, distance between grid loops, number of cells in the polar direction. Yeah, that's kind of interesting too. So you can play with both of those kinds of things. I have more or less of them. This seems to want to really be a small value, so I might make that number pretty small. And in fact, really, this is one of these things too where I feel like the scale of this thing is probably wants to be a little bit. Let's go ahead and flatten this, and then I think I don't think it should be all the way to the edge. Oops, what did I do? Polyline curve. What did I break? Insufficient points. Oh, because I scaled the cell outlines. Yeah. Okay. Can I scale the points? Yes, I can, apparently. All right. So that's going to give me a little bit more room on the outside if I just go ahead and scale that whole set there. I probably should have done that from the get-go. I think I did something. I don't know. Looks like it. Anyway, so something to keep in mind. The other thing would be to keep in mind would be to actually change the boundary, and maybe that's what I should do. Actually, let's go ahead and do that. I don't know if that's gonna change things. Yeah, that's right. Okay, that is what I should have done. Sorry. There's different ways to do things. Okay, so that's gonna give me, yeah, really nice. Okay, so kind of a radial effect for that, and you're gonna get this warning. It's okay. Still gonna work in this case, but that gives you a lot of different variations with that. Let's see here. Yeah, to a certain point, until you start to break it. Okay. Last thing I'm going to talk about is something called metaballs. And the idea of a metaball, I'm going to go take us all the way back to points again. I'm just going to make a couple points. Make a couple points. In this case, it being at 0 doesn't really matter a whole lot. Let's see here. Point. Okay. Metaballs live under mesh, and we're going to use the metaball custom T. And we got a point, and we got a point. And we still need charges. So metaballs are kind of the idea of some kind of physics-based particle or something made out of like slime, and they kind of ooze together. I'm going to show you what that looks like. So drop a merge component, and I'm going to drop a couple sliders with, let's see, 0, 3, I don't know, 10, I guess. I don't know. It's hard to judge my distance on these things. Okay, and then plug that in for C. What this does is just basically just takes these two things and puts them together so that I've got 2 points, 2 charges, and I can just kill that. So just zoom in and delete that. So that's what merge does. And let's see here. If I move my point along, yeah, so they start to kind of ooze together here. And in fact, to make this a little bit easier to visualize, I'm going to go ahead and pipe that into a curve and then hide this. There we go. And so they're kind of like, if they get too far apart, say they get closer together and they kind of ooze together. And you have more charge. You've got one that's kind of it's kind of stronger than the other. And you might have one that's kind of smaller than the other. And you'd say, well, okay, what's interesting about that? Well, it's kind of a way to create an organic kind of form, something similar to this. If I go back to some of the early examples, like these kinds of things, right? And even these could even be like a metaball of a certain type. Um, and so you can say, well, okay, what do I do with that? Well, excuse me, if you have a line or a curve, you can divide the curve and you can go into that and set that for your points. Now, it's not going to work because you need the same number of charges as points. And you do it a couple different ways. One easy way to do it would be just to do repeat data. And repeat data is just like it sounds. You're just going to create a repetition of something. And the data is D. So I'm going to repeat this number. And then L is the length of the pattern. And the length of the pattern is as simple as whatever number of points you put in is the number of times you want to repeat that. So there's 10 eighths, 10 points, 10 eighths. Plug it in for the charge. And what do I break? Let's see here, 11 points. Gotta do some math here. Counting. So +1. There you go. Kill these now. Oops. There we go. So you've got your metaball snake. So the further it's like a intestine or something. So you pull this too far apart, they're not going to have enough charge. You pull them close together and they're going to bunch up. And it's kind of neat. You actually get this kind of trail going. And so that's how that would simply work with metaballs. Would be something along those lines. You could also do something a little bit more complicated and throw a random in there. And so the same difference, like the number of things equal to x plus 1. Sorry, I know this is off the screen here. X plus 1. And the range is going to be, you can plug this in and 0 to 8. And the seed is just a seed. Just plug in some slider for this. Let me get rid of that. And then n goes into n. Okay, it's cleaned up here. And numbers go into charges. And now you've got just random, kind of charges and stuff. And depending upon, how you manage that and how you manage your curve, that's going to give you different patterns of things. So it looks like a little paint spill. And you can certainly play with that. And that's kind of a quick way to get something that's kind of organic looking. And to kind of bring this home, I mean, something you could do would be to take, if you had some kind of a shape, go back to our old tricks that we had before. So take that curve, set it, and then we're going to make a boundary surface. Go populate geometry. Well, and once again, probably want to offset the curve first. And I like offset better than scale because I feel like offset respects the geometry better. If I just scale it from the center, especially if it's an odd object, it's not actually going to give me like a really good line. It might be shifted somewhere even outside the form, and I don't really like that very much. So offset is going to offset from each of the corner vertices and it gives me a cleaner form. So I just did that. So now this boundary and that boundary are going to work together to give me something. And then if I go in and I've got, let's see here. So yeah, I have myself another number slider with a lot of points in it. We're not going to do a curve anymore here. And we're going to plug in the same number for the random number and the points for this. And what did I break? Let's see. 50. Oh, so this one doesn't need this. It's just going to say nothing. Ah, there we go. Just keep an eye on that data. If it doesn't like the number, just add an expression or change it. You should be good to go. Let's see here. So my charge is still kind of big though, so I'm gonna go there. And I didn't do it this parametrically, which I should have. I did it really quickly, but I'm just gonna offset it manually until he gets. This is the boundary. Okay. You can see that these things don't really respect it, so looks like you have to pull it in a little bit more. That's okay. So now I've got my weird kind of pattern, that's inside of this thing, this spill. And I can change the number of things, and I can change the seed of them. Actually, I'm doing that backwards. Sorry. The number of things, and the seed, and the strength, and I get more or less of a spatter. There's lots of variables. Strength is a variable. The number is a variable. The seed of the randomness is a variable. And then again, you can just take this outside thing and this inside thing. I mean, if you want to make it something, just take the outside surface, pipe in with a shift the inner surfaces. Just flatten them. And you've got surface. You can 3D print that. I mean, you can extrude that really easily too. Just extrude it, a little bit of the unit Z. And you can certainly print that or laser cut that. All right, so there's a lot of different methods you saw for making some organic surface types, which is like basically all kinds of things that you could laser cut, or you could CNC or plasma cut. And you saw how we can get, kind of organic shapes, kind of random organic shapes, these kind of like metaball kind of blobs, regular holes in a shape. It's all kinds of things you can do that are pretty simple. If you just understand, points, all kinds of ways of getting points randomly, and also curves, making sure that we're offset from the edge, making sure that we understand the the different effects that we're applying. And yes, there's a lot of variety. So anyway, I'm going to give you guys a script that contains all these different methods. But the assignment is just basically to create one of these panels. I would recommend you do something that's kind of odd shaped and just kind of see where these things kind of break and how you can play with scale and how much control you have over them. It's really easy to do a rectangle. That's what a lot of these things want to be. But as you can see from some of the examples, these are not usually regular shapes. Like they might be five-sided or they might have a crease in the middle. And so those are all things you want to be taking into account now. And yeah, all right, I will see you around.